In Britain, many thousands of men are working all the year round, just turning out new locomotives. The demand of today is speed, speed and still more speed. Longer trains call for bigger and better engines. Exacting requirements for an exacting task, but Britain's engineers are equal to it. Every new engine has to make its first appearance on paper. More than 370 drawings of the numerous parts have to be worked out and prepared. When plans have been approved, a specification is prepared. This is a volume that runs to 361 pages and contains more than 2,500 items. The specification is broken up, and each department receives details of its particular share in the job ahead. Industries all over the country benefit, and in due time materials start arriving at the works. The main frames, which may be called the foundations of the engine, arrive in the form of flat steel plates weighing 3 tons. This slotting machine eats through 10 plates at a time. Drilling the plates to take the various rivets and bolts is done by a multi-boring machine. Cutting, slotting, drilling and the final trimming reduces the weight from 3 tons to 2 1/4. Now the plate is guided into position alongside its twin. Foundry work is rather paradoxical. It is what isn't there that matters. A mould eventually consists of an ordered assembly of spaces into which the molten metal is poured. Over 60 moulds and cores are required to make a pair of inside cylinders for our engine. Skilled workmen fashion them in sand from patterns made of wood. The assembly of the cores in a mould is a task something like fitting together a giant jigsaw puzzle. A 12 hours drying causes the sand to assume a consistency which enables it to withstand the great pressure of metal soon to be placed upon it. Casting is worrying work. The cupola has to be tapped at precisely the right moment, and the 4 tons of white-hot seething metal taken to the site of the cast immediately. The critical moment arrives. Over she goes. The aperture into which the metal is poured goes by the name of the runner box. It acts as a sort of funnel. The foundry foreman takes up his position and, carefully watching, gives the signal to pull the plugs immediately the cast is complete. This allows the gases given off by the hot metal to escape. Metal may set too quickly near these plug holes, and these men, carrying out an operation called feeding, are preventing this from happening. 1 or 2 days to cool, and the mould is ready for breaking open. A crane fixed to the actual cylinders draws them away from the moulding boxes. Men with crowbars break away the sand so carefully and skillfully fashioned by the moulders. Pretty hard life, the moulders. All his work seems to end in dust. Leaving the foundry with its glare and dust and smoke, our next port of call is the heavy machine shop. Here the cylinders are milled and bored, a tedious but highly important job, requiring a high degree of accuracy. Holes are drilled to take the securing down bolts to the saddle on which the smoke box will be fixed. Now for our first bit of real engine building. Completed cylinders meet the completed main frames. Add the 2 outside cylinders and the frames are ready. Machinery does not reign supreme everywhere. Here in the smithy, the merry ring of the anvil can still be heard, and brawny arms wielding the hammer still strike sparks from glowing metal. In the midst of modernity, the ancient craft of the smith still holds a place. All manner of smaller parts are made in the smithy. Nuts and bolts in all sizes and variety, rivets by the tens of thousands, washers, springs and small forgings. They are all part of the grist that comes to the smithy mill. To many, a boiler is just the round barrel part seen on any engine running about the line, but many are the mysteries hidden beneath its rounded sides. The plate just going into the furnace is the bottom half of the throat plate, or the saddle plate as it is sometimes called. Its purpose is to join the barrel to the firebox. The gas-fired furnace soon brings the plate to the required heat, and it is craned rapidly to this huge press, capable of exerting a pressure of 700 tons. The blocks between which the plate is squeezed themselves weigh 41 tons. Batteries of machines, each designed to do a particular job, cut and drill the various parts of the boiler, searing through the tough steel as though it were cheese, until finally they are ready to be assembled. The first step in the assembly of the boiler is the joining together of the three sections of the barrel. The saddle plate, which you saw in the press, is now being attached to the barrel. Rivets, rivets and more rivets, adding strength to strength. 250 pounds of pressure to the square inch takes a bit of holding, and hold it the boiler must. The inside copper firebox and the outer steel casings are securely held together by more than 2,500 stays. The stays are screwed in and the heads riveted over. This is where the mysteries go in. A modern engine has a big appetite for steam, hence her large grate area of 45 square feet and her high amount of tubing. First to go in is the main steam pipe, through the center of which will later go the rod connecting the regulator handle to the valve. Now the smoke tubes. There are 112 of these, each 19 feet 6 inches long. The 32 superheater tubes which are screwed to the firebox tube plate are the same length. If you care to work it out, number 6207 carries more than 2,700 feet of tubing. Meanwhile, things have been happening at the other end of the boiler, and some familiar objects have been finding their way onto the fire door plate. This is the regulator handle. We leave the fitters to get on with their job, while we take a look in at the steel foundry. It's time number 6207 had some wheels. The mold that forms the wheel is made in two halves. Sand is placed round the first half pattern. The pattern rammed up, the hole is turned. Over she goes. Remove the baseboard, and out comes the pattern of half of the wheel, to leave a perfect replica of itself in sand. Now the other half, made in the same way. Then the two halves of the mold are joined together. The molding boxes are clamped, and our wheel is ready for casting. Molten steel looks hotter and is hotter than molten iron. In the steel foundry, the ladle travels on a sort of overhead railway, and when it comes opposite the mold, the metal is released. A few hours to cool, and the mold is ready for breaking open, and so a wheel is born. To its making has gone 3,500 weights of the finest steel and all the skill and experience of the steel foundry men. After the machining has been completed, the wheels are mounted on the wheel press, which joins them to the axle. In pressing wheels onto the axle, this machine exerts a pressure of 150 tons, so that there is no fear that wheel and axle will ever part company. Next, the wheels are ready for tiring. Heating the tire, which is lying on the ground, causes it to expand, so that the wheel center fits into it quite easily. At normal temperature, the tire is 1/16 of an inch less in diameter than the wheel center. As the tire cools down, it shrinks firmly and securely onto the wheel center. Our next job will be to provide the motion. The various parts of the motion, which can best be described as the moving machinery, start life in either the drop forge or the heavy forge. In the drop forge, the article being manufactured is stamped out in a shaped die. In the heavy forge, the article is shaped largely by the skill of the smith. These men are making a combination lever. A machine trims off the surplus metal and the job is finished. A connecting rod enters the heavy forge as a rectangular block of steel, weighing 12 hundredweights. Eight tons of steel hammer descending on steel thuds solidly. The iron floor trembles at the impact. Owing to the intense heat, the men wear these strangely looking caps to keep the sweat out of their eyes. Hand, eye and hammer work in perfect unison, shaping, squeezing, forcing the reluctant metal to the will of the hammer and to the will of the men of the forge. 5 times into the fire, 5 times under the hammer. The maximum amount of work must be done at each heat to complete this amazing achievement, so that the men of the forge must be both quick and sure. Who will say now that the day of the craftsman is no more? Machining the flats is the first operation in the machine shop, a process that gives a glass-like surface to our rods. To reduce the weight of the rod, the sides are fluted, and this is the machine that does the job. Circling the ends, as it is officially called, seems to provide a fitting description of this operation. Holes have to be bored at either end of the rod to take the bushes. Now in the erecting shop, the piecing together of those parts which have been so carefully wrought in the various shops. Heat is precious and has to be conserved, and this is how it's done. The aluminium alloy foil is quite a recent discovery in this lagging process. It has been found to possess remarkable heat-resisting properties. After the fixing of the lagging sheets, the boiler has to be mounted on the frames waiting to receive it. One of the most amazing sights is the way heavy loads, even the most awkward and cumbersome ones, are slung about the works. A screech from the overhead crane, grappling hooks descending out of the air en route, and almost before you can say knife, a loader from 50 tons up to a complete engine is whisked away to a new position. Number 6207 is really beginning to look like an engine. You don't put wheels on a locomotive. You put the locomotive on the wheels. It is wonderful to see this huge load handled with such ease and placed exactly where it is required. Here she comes, finest of her class, pride of the line and of the men who built her. Over 90 years of experience have gone to her making. Lifeless as yet, steel hawsers draw her slowly into the open. Soon she will be rushing over the main lines at 80 miles an hour, hauling trains of 500 tons or even more. She's off. A 1,000 men have served her in the making. How many thousands will she serve during her life on the line? Here's to you, number 6207. Good luck and good running.